put on Saturday. I got no rhyme or reason for it. I like to stay pretty casual.
It's cold in here.
They're going to their
Oh, why did they bring you?
together. I went to Sam and I don't remember his name.
You're old enough now?
Did you finish your little
Ever since I was on,
I started was pretty easy.
no, voice
You
practice
started?
today.
Yeah, you're right. We're
No,
It's the same password as every.
Yeah. That was weird. Did you hear me?
Have you ever been on
No,
Q?
he just did.
No.
Yeah, like it's not
You
gonna
have
happen
never
today.
been on Q. I don't remember. What's your password? I should have got
What
an
is not
email.
gonna happen?
What? I should have got an email.
What's not happening?
And voice crack.
You are.
Alright.
Are you in health?
No, always.
Okay, alright, today we're just gonna do a couple notes, pretty straightforward. I wanna talk about what section we're going into. On Monday, or I should say Friday, we will finish it, right? So today, we are gonna talk about section 1819, we're mixing them together. Now, just so you know, we did have an assignment yesterday, so like Alex, I know you were gone, that was page 27. It was 1 through 4. On those, they just give you a list of numbers. They wanted the mean, median, and mode for that list. So those are the 3 different numbers we talked about. Okay, and again, we did have homework due today. That's the division part, the page 23, 1 through 15. I think most people have turned it in. If you haven't, that's due at some point today. Okay, today we're just gonna do notes. Very easy. We'll do notes before lunch, after lunch, and we'll probably be done a little bit early. Okay, so you can get things wrapped up and turned in. Okay, but we're on section 18 to 19. I always mix these two together because they go hand in hand. So we have some basic terms we need to talk about today, some vocabulary. So, like always, we always have vocab terms, but these are kind of important because these are words that you probably have not seen before. The previous words that we've definitely talked about, you've had before, it's a refresher, but today is really kind of the start of new stuff. The main words we need to talk about. We need to talk about exponents. We need to talk about leading coefficients. We need to talk about a base. Okay, those are like our main topics. Then after lunch, what we'll be doing, actually maybe before lunch, we're going to talk about the order of operations. Talk about that. It's one of our things that it's going to be one of our main topics, and then that leads us to one of our last things, which is the actual order, which I'll explain this little acronym a little bit later. Okay. Okay, so that's kind of our lead into what we're going through. Anyone seen Jason today? See, I wonder if he's marked absent. Yeah, he was marked. He had a doctor's appointment. Alright. Okay, perfect. Okay. But yeah, let's jump right in. Let's talk about some vocab terms. We'll talk about what this means. Alright, so I'm gonna just start with a very basic thing. I'd like you to have this down. This is our example day. We're gonna go off our vocab words off of this topic today. Okay, this, what you're looking at here is an algebraic expression. Okay, what I mean by algebraic expression, it's a simple item that has numbers and letters combined with basic operations. That's what it is. So numbers and letters, and numbers and variables. And they're combined using basic operations. Okay, the basic operations that we should know: add, subtract, multiply, and divide, right? That's what the basic operations are. But there's a couple vocab words here that we need to make sure that we know. So I'll start using them today, especially on some of these problems we're gonna get. And I wanna make sure that we're comfortable with them, okay? So far you've practiced all the basic operation stuff. We've practiced adding, we've practiced multiplying, dividing, subtracting. We've practiced everything, but now we're gonna put it all together in kind of a single problem. Okay, so let's start with the first thing, okay? This 2 actually has a name. It is called the exponent. Okay, how many of you have actually heard that term before? Exponent, okay, good. So at least it's not crazy new, but there's another word we tend to use instead of an exponent. Anyone know what that means? Anyone know the other word we use instead of exponent? Okay, squares, definitely. But we're talking about the powers. So like, sometimes we'll refer to it as the power of 2, that type of thing. But you're right, it's called the square. Power of 2 is called the square. So I'm gonna put that in quotes. We call it the square. Okay. We have a power of 3 that has a different name. Everything else, any other powers other than 2s and 3s, we just call them like 4th power, 5th power, 6th power, something like that. Okay, the x on the bottom. Ooh, jeez, marker's fading. The x on the bottom, this is called the base or variable. Because obviously it is a letter, so sometimes we call it the variable. Bases can have powers, as you need to realize. It could be anything. I can put anything for that base, and I'll do a couple examples later. But bases have powers on them. And then the number out front, this object, we call that the leading coefficient. Okay, leading coefficient is just the number in front of the base, whatever that is. Okay, so those are your basic vocab terms. Now, what I want to discuss is, what does this mean? Like, what do we use this for? Like, what's the purpose of it? So we go back to that problem here. Okay, so how we pronounce that 3x squared, that's how we say it out loud, but what does it mean? What is the power of 2 actually telling us? Well, the item that has the power of 2 is just the x. That's what you need to realize. Just the x has a power of 2, so the 3 is kind of by itself. And these are being multiplied. That's what you need to realize. So I'm going to put a little dot in between there. So it's 3 times whatever x squared is. And then what the power of 2 stands for, it stands for this. That you're going to take the base, which is the x, and you're going to multiply it on itself. That's what a power of 2 means. That's what square means. So when you look at the base, and I write this out, like what this actually means. How many of the x's do I have here?
2.
That's what the power means. That you have 2 of them. You have 2 x's being multiplied together. You don't add, you multiply. This is what we call expanded form. It's expanded form. It is the true definition of what a square is, or a power. That's literally what it means, that you're taking it times itself. A lot of people always think, oh, I'm just going to multiply by 2. That's not the real thing. The real thing is you expand it out, and then you do the math, whatever that is. Okay? Now, just to discuss, like how we can use this. We can put numbers here. I could say this is 6 to this power of 2. So now on this type of problem, what's my exponent?
2.
Yeah, 2, right? That's my exponent. It's a square. Okay, the base is the 6. I know that's weird, right? The base is not a letter, it's a number. It's fine. This is called a numerical expression. Still an expression, right? No equal signs, nothing like that. And there's only numbers that are involved here. We don't have variables. So it's not algebraic, it's just numerical. This problem has an answer. There's like an actual digit for an answer. And we still do the same math we just learned a little bit ago. Right? Now on this one, there's no leading coefficient. We just have base and a power. Okay? So if I go to the 6 to the power 2, right? 6 squared, that's how you'd say it. What does the power 2 actually mean?
6 times 6.
Exactly right. That's expanded form, right? 6 times 6. So your answer is actually 36. That's what I'm looking for. That's what I want you to realize. So whatever the power is, it tells you how many of them you actually need to multiply together. So if I did something else, somebody give me a small number. 2, okay. Give me a power that's bigger than 2.
5.
5, okay, 5. Well, what this means, my base is this is the exponent, means I'm taking 2 times itself 5 times. That's what it means. I'm not taking 2 times 5, I'm taking 2 times itself 5 times. So if I do this correctly, this turns out to be 4 times 2 times 2 times 2, that's the first 2, right? Multiply these, that's 8 times 2 times 2. Multiply these, that's 16 times 2, and then 16 times 2 is 32. That's the idea. Okay. That's how you do that math. You just whittle your way down, just do 2 numbers at a time until you get down to the final answer, and that's the number I'm looking for. That's evaluated out as far as you can. Okay. They're gonna ask you eventually, I don't know when we're gonna have our assignment, we might have one tomorrow maybe, if we get there. They're gonna ask you to evaluate these types of things. I give you a problem, there's some powers on it, you have to figure out what the number is in the end. Okay, it's not bad. Now, here's what I want you to realize. The base makes the big difference. Powers, yes, but the base did. Because look at this, this only had a power 2 and the answer was 36. This had a power 5 and the answer was 32. So it really matters what the base is, because that's the idea. Some people always, they don't think like the numbers are really small, right, when the powers are. But it actually matters what the base is. So the bigger the number, the faster it grows, okay, for that base. So let me give you an example of what I mean by that. If I pick a bigger base, because I kind of limited you on what I wanted a small number. But if I pick a bigger number, let's say like, let's go like 15. If I do 15 and I put it to the 3rd power, that is a massive number. It is huge, okay? Because you're taking 15 times itself 3 times. Okay, when you take 15 times 15, you get a number like 225. And then when you take it times 15 again, you get a bigger number. Okay, in fact, I don't even know what that is off the top of my head. What is that? 5, carry a 2, that's a 10, plus 2 is 12, carry the 1, that's a 10, plus 1 is 11. The little turtle egg or whatever you have, so I'm skip that number. 5 times 1, 2 times 1, 2 times 1, adding straight down, 3,375. Look at how big that got. Just because I had a power 3 on it. Power 3 got me to the 3,000s already. So it makes a big difference with the bases. That's what some people always get confused on. I know for a fact we're going to look at what powers can do later on when we get to like the powers of 10. We can start looking at scientific notation. That's going to be one of our things we're going to eventually look at here. I just want you to realize some of these numbers get huge. So don't like go crazy on the powers, right? Because you still have to work with it. To give you an example of what I mean by this is imagine that you're going to start work here, right? This is your first day at work, right? And you're going to work for, let's say you're going to work for 64 days during the summer, and that's your ending point. Okay, so you're going to work for 60 days, then you got to take a break because you got to go to football or volleyball or whatever you're going to do, right? You're going to go on vacation or something like that. Just to give you an idea of sense of power. if you work during this time period, like you work full time and your boss offered you, $10 an hour. $10 an hour for every hour you worked. Is that a good deal? Yeah, I mean, minimum wage is what? What is minimum wage anymore? 7 something, or is it 9? What do they have it at right now? 8 something? I don't even know anymore. Okay, so $10 an hour, most people are like, yeah, I'll work for $10 an hour doing whatever you need to, and you work for 8 hours a day or whatever it is, 6 hours a day, and you get $60 a day, right? But if your boss offered you 1 penny on the first day, and then doubled it every day after that for 64 days, doubled it, you can make way more money. Way more money than getting $10 a day, okay? Or $10 an hour. Because it's the idea is that for 64 days, this idea of this penny is actually based on like powers. Because every time you're doubling it's like taking it squared and then adding it to itself. So the idea is that powers can go faster. In fact, I think when my professor did this in college, he actually did the calculation of this. You'd almost be a millionaire in 64 days if your money doubled every single day. It'd be like after the first week you're already in like maybe I think the hundreds of dollars range that you've already made all summer. And then you keep going, it keeps doubling. So it's crazy how this works. So it's just this idea of power, I think, escapes people. They don't realize the power and like how big numbers can get with just small numbers like 3. Alright. So we talked about exponents, talked about leading coefficients as numbers out front, we talked about bases. Now, how can we apply this to the type of math we're going to be doing? Well, the type of math we're going to be doing is problems like this. This is the type of math we're going into. Most people look at it and go, oh, okay, that's fair enough, that's pretty easy. Okay, here's what I'd like you to do. I'd like you to write this problem down in your notes right now, and I want you to solve it. Just give me the answer in the very end. Don't say it out loud, just solve it. Okay, now, if you put the number 32, you got it wrong. It's not 32, okay? Your number should be 17, okay? So, the idea is that it's this. Yeah, it's the order of operations. The order of operations tells you that you should do parentheses first, if you have any. You should do any exponents, like we were talking about over there, which we don't have any, and now you want to multiply and divide first. So I look at that problem and I want to multiply. I want to take the 3 times 4, which is 12. And then, if you have no more multiplying and dividing, then you go to add and subtract last, which I have 17. That's the answer. You wouldn't believe how many people would put 32 there, because they see this, they read it like a book, and they go, oh, that's 8 times 4, and that's 32. You're not supposed to add first. It's this order. So the reason why they have the order, this, is so that it guarantees that everyone gets the same answer every single time. That's why they have an order of operations. Okay, so they're guaranteeing that we'll get the same answer, the 17, every single time. But again, what this stands for. So PEMDAS, right? I think I had this little acronym when I was in school. I think my teachers called it, please excuse my dear Aunt Sally. That's what my teacher said. Okay, and the P stands for parentheses. Parentheses, there we go. Parentheses are any type of brackets. Brackets, you have to go inside of them and work that. Then the E stands for exponents. So you do those second. We'll do a couple of examples where you have to do that. So you do those next. After you're done with all the parentheses, you do the exponents. Then the multiplying or dividing comes next. And notice I put these side by side. I don't care which one comes first. You have to go left, right, like you're reading a book. So multiply or divide, because they mean the same thing. Multiply or divide. I'll explain that concept later, why they're the same thing. That'll come up when we get to the fractions, way later, okay? And then the last one is add or subtract. And again, adding and subtracting are the same concept. They are the same. So you just go left to right, whatever one comes first. And that's add or subtract. And we'll come to that when we get to the integers, which is a later chapter. It might be chapter 3 or something like that. Add or subtract. Okay, so now that we got a concept of like why we use this, let's do a problem where we have to put some of this stuff together. Okay? Alright, so here we go. I'm gonna leave that on the board just so we can use it. Let's do a larger problem. Actually, I need a bracket. That is a menacing problem. It's got almost everything in it, except for division. I guess division is the only thing we don't have. Alright, so the idea here is that we're gonna have to look at parentheses, we'll have to look at exponents, multiplying, dividing, adding, subtracting. Okay? Now, we could get negative numbers, totally fine. If we get negative numbers, we'll try to explain as we go, because I know there is a potential we'll get a negative number in here, which is fine. That can happen. And that's part of our integers that we need to get used to. But we're gonna try to do everything at once. So, by the order of operations, what should we start with first?
Parentheses.
Parentheses. So, what I mean by parentheses, as you go left to right, you start here, and you go left to right, like reading it like a book. You need to jump inside the parentheses, and we start over. Okay? So we're gonna start here, and work our way left to right, and see if there's, and we start over. So we're looking, is there any more parentheses? Yes. We have to jump inside that. And we're gonna go, and we're gonna finish that math first. So what is 3 plus 4? 7 squared parentheses. Alright. Notice, I did not do the thing out front. No. I followed the order of operations. Because most people make the mistake, they try to add these numbers first. I already got it wrong. You don't do that. So we're inside now. We did the 3 plus 4, correct? So now I'm gonna get rid of this parenthesis, because I don't need it. I'm done with the parenthesis now, I finished that. What is 7 squared?
49.
49, 7 times 7, right? That's literally what it means. And notice I'm doing that first because I'm still in this parenthesis and I'm still finishing it. So I'm going exponents, I'll try to multiply and divide, try to add and subtract. Until I get done with the parenthesis. When the parenthesis is gone, then I can continue on the outside and do the same stuff. So 7 times 7 is 49 like you said. And yes, these numbers turn out to be very, very large. So now, 4 minus 49. Well, that's negative 45. It's negative, because you're taking 4 and you're subtracting a 49. So now this is our first chance of getting a look at negative numbers. And now, I'm technically done with the bracket, right, because I did the math inside of it. So technically this turned into, instead of a bracket, it has now become a parenthesis. But we're still not done, because now as I'm going left to right, I have multiplying. That's what the 3 in the parenthesis means. That this turned into multiplying. So 3 times a 45, it's actually negative. So it's a negative 5 carry 1, 135. Zowie. And then you take 4 and you subtract 135 off of it, which is a negative 131. Okay. If you have this written down, let's go to lunch. We'll come back, we're gonna look at some easier problems other than just throwing you in the deep end.
3.141592653, whatever.
I want banana cream.
Banana cream pie?
Yes. My favorite kind of pie. You need to be pumpkin, but
You don't have to be looking at me. Why do I have two bottles?
banana cream pie. Banana cream.
You're down short.
Okay. Perfect. Okay. What we're gonna do right here after lunch, we're just gonna do a couple examples of doing this order of operations, but with easier problems. Now, I threw you in the deep end. I want to see if you could at least follow along with what I'm doing there. Your problems will not be that complicated. The reason why I say it's complicated, there's brackets and parentheses and exponents in there. We're gonna just kind of have one of each when you look at a problem. So I'll give you kind of the style of problem that we need to get used to, so you get kind of a feel for it, and then we'll see kind of what we can do from there. Okay? All right. So this is kind of what we're doing, but let's pick an easier style of problem. That way we can get comfortable with it. All right. So here we go. Let's try this. 2 times 2 plus 3 minus 1 squared. Okay, so I'd like you to write this problem down. This would be like something that we would be probably having in our problems. Something very basic. It's a numerical expression. Not so many steps. 1 or 2 steps kind of gets you down to the end. The numbers are relatively small, so you don't have to worry about them. Try another one out. We might try a little bit bigger problem on the next one. Okay, so I want somebody to kind of walk me through what would be the first step that you would attempt. Cole, what do you got?
You would do whatever parentheses.
Parentheses, so what do you get?
You get 2.
2, okay. So that is correct. That's what I would do first. Now, I don't even need to write that parentheses, I'm putting it there just so you know, like, that's what we did first. Okay? Any questions, comments, concerns about that? That was good. Next up, somebody else, please. Okay, what do you got there, Alex?
You gotta do what do we call it? The exponent.
The exponent, right? What is 2 to the power 2?
4.
4. He's absolutely right, because it is literally 2 times itself. It's the base times itself, because they have to have 2 of the bases, right? So you're absolutely right, you get the number of 4. Right? So that's what we had to do first. Now I wrote out the expanded form because that's what this means. 2 squared is 2 times 2. Right? So that's 4. Okay, next step. Okay, what do you got there, Ben?
Do 2 times 10.
2 times 2, because you gotta keep multiplying, right? So 2 times 2 is
4.
4. Alright, and the last step, pretty obvious.
4 plus 4.
Yep, which is 8. Okay. That's what we have. Now, obviously, when you're doing these problems, you're trying to get down to the final digit, the final numerical thing, where you're trying to evaluate these problems. That's kind of the topic that they say. Alright. Any questions about that problem? Pretty straightforward, pretty easy, I think. Okay, now let's do one that's a little bit larger. Okay, something that has a little more terms in it, has some different concepts, maybe multiplying, subtracting, division. Maybe in this next one we'll try. Alright, so let's go with 6 plus, let's go 7 times 2 divided by 3 minus 2 squared plus 8 times 4. Okay. Longer problem, right? Not any more difficult than the last one, just longer. It's got the same concepts in it. Okay, so let's go through this one. I know that you guys are still writing, but we'll try this one out all together at the same time. We'll see kind of what you're doing. I wanna hear different people throwing different things here. So we'll kind of start, whoever wants to start here first, we're just gonna go around and we're gonna try. Okay, Cole, you're gonna start us off.
You have to do in parentheses, so it'll be 1.
3 minus 2, you get 1, okay? I don't need the parenthesis on there, you can leave it like this, that's fine. So you're absolutely right. So 3 minus 2, so that was a good way to start. Alright, somebody else please. That was good so far. Next, Alex.
Hey, just the exponent again.
Okay, exponent again. So what's 1 squared?
Just 2.
Nope,
1.
1. 1 times itself. So you get the number 1, yeah, that's the part that you're not multiplying by 2, you're taking the bottom, the base, times itself. So there's 2 of the 1s. That is the number 1. Yeah, some mistake, it's easy fix. So, alright, I like it, I like it. Okay, next, please. Now comes the tricky part. Okay, Beth, what are you thinking?
Can you do 7 times 2?
You're absolutely right. Because now we're done with all the parentheses, we're done with all of the exponents. Now we're going left to right, you are multiplying and dividing whatever one comes first. You're absolutely right, 7 times 2, which is? 14, alright, this is good. Alright, 1 plus the 6 plus the 8, 3 plus 4, okay. So, good, somebody else now?
Okay.
Okay, what do you got?
14 divided by 1.
Is
14.
14, yeah. 14 divided by 1. If you divide by the number 1, it doesn't do anything. Right? It's like multiplying by the number 1. It doesn't change anything. So you're absolutely right. You get 14 again. That's nice. Somebody else now. Okay.
Why don't you do 8 times 3?
8 times 3. Because you have to keep going. Left to right, multiplying and dividing as you see. So 8 times 3 is? Heard it?
24.
24. Yeah, I thought somebody said it. 14 plus 24 plus 4. And now, I can safely say that the rest of this problem, all we're doing is we're just adding the rest. There's no subtraction, there's no parentheses. So it's pretty straightforward. We'll just add left to right as we go, because I think the numbers are grouped pretty easily. I'm going to put that problem, I'll put it up here, just so you can see it. I know it's getting kind of low on the board. So here's where we're at, we're right here. Okay, and now at this point, it doesn't matter the order that you add, because it's all going to be the same answer anyways, it's all adding straight across. So I'm just going to group them up, I'll add these two together, add these two. What's 14 plus 6?
That's 20.
Perfect, 20, yeah. 22 plus 4? 26, and now you can add these together, you get 46. That's how I would do it, just because it doesn't matter the order you add, so I just grouped them, that's all I did. You could have just kept going across, 20 plus the 22, and then add the 4, I mean, it would have been the same answer anyway. So there's your answer. If you could follow that, you're definitely fine. It's just, I want us to get used to what those exponents are, like what they mean, so that you're not like confused on how that works. Okay, yeah, so I know tomorrow we're gonna definitely watch a small video on powers, just to give you a glimpse of what types of powers can do, like how big numbers can get, with just simple powers like powers of 4s, 5s, and 6s. And we can talk about that in terms of like distances to give you kind of a real-time effect. Okay? Alright, any questions with that? Okay, we're going to stop there today. We have about 10 minutes. If you have not finished page 27, maybe you haven't even started yet, or you haven't finished page 23, you can start working on that. Page 23 is the one due today. That was division. So if you have anything to do, that's the one I want you to get done today. And then page 27 is technically due tomorrow. So, there you go. So. Alex, we got the other day. Here's an old assignment for you.
Do we not have school on Friday?
We don't
Sorry?
have school next Wednesday.
Next Wednesday, yeah. Yeah, because instead of, the 1 hour early out, we don't have school next Wednesday. All right.
page 23 the one that's due tomorrow?
Page 23 is due today.
Okay,
That's
then it's 27.
27 is due tomorrow, yeah, yep. Sure. I know.
Hey, Jason.
Hey, there's Jason. Perfect, thank you, sir. Alright, we did notes today, and actually most of them are still on the board. Just talking about order of operations stuff, so if you wanna write those down, we'll continue notes again tomorrow, so we'll try to get you filled in, so no worries there. So no new homework today. If you haven't got page 23 done, that way you can work on that, that's due at some point today. And then that page 27 we got yesterday is due tomorrow, so, yeah. Alright, geez, you guys brought a crew. Alright.
We're all
Okay.
confused.
Which problem?
25 through 28.
We kind of just
And
guessed.
26. We did not.
Alright, let's do one of those, so.
28, 28, 28.
We wanted.
No,
Okay, somebody's gotta read off 20.
Oh,
I got it.
You go, please. Let me get to the.
Yeah, read it real slow so we can kind of piece it together.
Wait, what number? 28.
28. I think that's the one you guys all agreed on.
Sure. Angle 3 and angle 4 form a linear pair.
Okay, stop there. 3 and 4 are linear pairs, so it's something like this. They make a line when you're putting angle 3 and angle 4 together. Okay, does that make sense?
Yes.
Okay, now I don't know which one's which. I mean, 4 could be the bigger angle, 3 could be the smaller one. Keep going.
The measure angle 3 is 4 more than 3 times the measure of 4.
Okay, so this angle, this is number 3, right?
Mm-hmm.
It is, what do you say again? Say to repeat that?
4 more than 3 times the measure of 4.
Okay, 3 times the measure of 4. Here's angle 4. This is angle 4 over here, right? This angle 3 is 3 times the other one plus 4. That's what they said, 4 more than 3 times the other angle. Okay, so this is what I have. That's the correct label. So it looks like I did draw my picture right, because this is the bigger of the 2 angles. What do they both add up to make?
180.
There you go. So you go 4 plus the 3x plus the other x equals 180.
Equals 1.
That's how basically you do 26, 27, 28. That's how you do them. You just have to see kind of what they're giving you. Draw the picture. So at this point, what do I have for x's?
4.
4 x's. Okay.
X equals.
So I'm gonna subtract the 4 across, so I get 4x equals a
176.
And then divide by 4, that is definitely a 4, carry 1, 44.
Okay.
Oh, alright.
And that's all the answer. We don't have to sub it back in.
No, did they, now on 28, what was the second, did they ask you for what is each angle?
Find the measure of each angle.
Ooh,
Okay,
find each angle,
so we
so,
have to.
so that means
Yeah.
this angle 4 is a 44 degrees. And then
you
the other
have
one
to
is,
sub it in for x.
yeah, it's common sense. If that's 44,
I know.
this angle over here, you can plug it in X, don't get me wrong, you can do that and figure out the number, or
180 minus 44.
exactly,
Okay.
like common sense. So 136,
Okay.
like
And
common
then
sense.
what would that be? Can I just name it Y?
Yeah, it's just angle 3.
I just named it Y.
This is angle 3, this is angle,
Or, okay.
Angle 3.
We had to like seal them, it was confusing.
okay,
Sorry.
that's how you do it.
Thank you.
I know we're gonna go over, I think, 27 for sure tomorrow in class, tomorrow, not today,
Tomorrow?
tomorrow. Cause I'm gonna make this assignment tomorrow, so.
Oh my
Yeah.
god,
Okay,
seriously?
so it's gonna be due tomorrow, cause we're not gonna have time in class today to talk about it, so it's gonna be due tomorrow. I'm gonna go over, I think, number 5, and then
Yeah,
27 in
did
class.
that. I got number 5.
Okay, alright, so bring those tomorrow, if you get done, you can turn them in, I'll just hand them back to you tomorrow when we start
No,
talking
I
about those.
kind of want to
Okay.
check over my answer.
Alright, there you
Thank you.
go. Yep.
Oh, guys, I'm alive.
No, you're not.
True, I should be dead.
Not something.
Quite the crew. They're all from different sections too, that's the funny thing, there's like 6 and 7, 8, there's a period 2 in there, so.
Now those word problems, it
Hmm?
really, the word problems really get you something.
Yeah, it's just because they don't know like if they have to add to make 180 or add to make 90 because that's the section they're in. So it's the idea that they said linear pair lines. So they're still getting confused on the terms. That's something we'll talk about tomorrow. Because there was one problem, I think it's 27, they mixed everything together. Where they said these two angles are complementary, so it's 90, and then these two angles mixing with those to make 180. Oh man, it's a nightmare.